Alright, let us look at another question from the chapter Areas Related to Circles. Four circular cardboard pieces of radii 7 centimeters are placed on a paper in such a way that each piece touches other two pieces. Find the area of the portion enclosed between these pieces. Now, the only way to understand this question is to first draw a diagram which represents what has been mentioned. Now, this represents what the question is mentioning. There are four circular cardboard pieces, each of radii 7 centimeters. So, you notice there is a square that has been formed by connecting the centers of each of these circular cardboard pieces, which are touching two other pieces as given in the numerical. And we can also notice that the distance from here to here would be 7 plus 7, that is 14, and the same applies in this direction. Now you can notice that I have connected the centers of the four circular pieces, and this forms a square whose dimensions are 14 by 14 centimeters. What we have been asked in the question is to find the area of the portion enclosed between these pieces, which means this area is what we are supposed to find out. So the manner in which we will solve this is first to find out the area of this square, which is 14 times 14, and from that we will subtract the area of the sum of these four sectors. Since the radii of each of these sectors is the same, adding the four sectors will give us one circle. So what we could do is we could write 14 square minus pi r square, and that will give us this central area. So we know the area of the square will be 14 times 14 minus pi into 7 square. So this is 196 minus 22 by 7 times 7 times 7. So 1 7 gets cancelled, and this is 196. 22 times 7 is 154. So the central area comes out to be 42 square centimeters. And that is the final answer. Now let us look at one more question. The length of the minute hand of a clock is 5 centimeters. Find the area swept by the minute hand during the time period 6:05 am to 6:40 am. So I'll draw a clock in order to explain what this question is talking about. As you can see, I have drawn two clock faces, one showing the initial time 6:05 am. Let's say the hours needle is here pointing to just beyond 6, and the minutes hand is at 1, which is indicative of 6:05, and the final time is 6:40 am, which is when the hours needle is close to 7 and the minutes needle points to 8. So what we need to do is find out this particular angle which I've shown in the first figure. So if you notice, the minutes needle is at 1 and finally it arrives at 8. We know one full turn from 12 back to 12 comprises of 360 degrees, which accounts for 60 minutes. 60 minutes accounts for 360 degrees. So 1 minute accounts for 360 over 60, that is 6 degrees, which means 1 minute is equal to 6 degrees on the clock. So now if you notice, in moving from 1 to 8, we are covering 35 minutes. So therefore 35 minutes accounts for 35 times 6, which comes to 210 degrees. So this would be the theta value while calculating the sector area. We know the sector area formula is pi r square theta over 360. The radius is given as 5 centimeters. R is equal to 5 centimeters. So let us plug in the numbers. 22 by 7 times 5 squared into 210 divided by 360. 7 cancels this 30 times. 0, this goes 12 times. 6's are 11's are. So 11 into 25 divided by 6 would give us 45.83 square centimeters. So the area swept by minute sand is equal to 45.83 centimeters squared. And that is the final answer.